Hey guys, welcome to another episode of CUDA Education. So we've kind of we've gone through the at this point we've gone through the shader groups conversation. We've gone through the independent shader files, so the raygen shader, the miss shader, and the closest hit shader, right? And we understand that when we have our triangle, if the ray is generated and it doesn't hit anything, it's this blue color. But if it does hit the geometry, which you know which would be the triangle in our case, which is the bottom level acceleration structure, right? If we hit the triangle geometry, we get different colors, right? So we kind of understand that. We understand the miss, and then we understand raygen because we played around with what counts as an intersection and what doesn't count as an intersection and all that good stuff. And like when we zoom in and zoom out and we play around with these values here, that the triangle would disappear based on the camera eye is like a sphere. So like initially, if think of the camera as like a sphere, and then when you zoom in, you might just see this initial part, and then as you zoom in more, you see more and more and more until you see maybe just this right here, and then as you get in closer, you're going to see the whole triangle. Here we have it to a very long distance, a very long distance. So the whole triangle, no matter how far I zoom out, or obviously I zoom in, you're gonna see the triangle, right? So we kind of understand that. So I was of the opinion, okay, I got this stuff figured out. Like I know what is going on. I understand. I understand. All of this stuff. I'm feeling good. But the problem is that I kind of forgot about this conversation here. Create shader binding table, and I'm like, and there's a lot of stuff going on here. So you know what I mean? I was like, I forgot about this, and it seems important because there's a lot of stuff going on. So, I know that if you look at the ray tracing 4 videos, I kind of glossed over this stuff. But now that I have a better understanding of this stuff down here, we could now revisit the we have a better understanding of this stuff here. We can now revisit what the shader binding table is, right? And kind of give it a little bit better context. So this is my initial video, again revisiting it. I know I did some ray tracing 4 videos, and I sort of glossed over it, and I'm going to gloss over it a little bit again in this video, but I think I have a little bit more information. So um the shader bind right, okay, so the shader binding table is, from what I understand, right, so my slightly better understanding of the shader binding table is a link between the ray tracing pipeline, which is a Vulkan thing, right? The ray tracing pipeline is a Vulkan construct, right? And the the acceleration structures slash shaders, right? So the shader binding table again is sort of a bridge between acceleration structures, ray tracing pipeline, and the shaders. Okay, so that's my better understanding of it. So the ray tracing pipeline is the ray tracing pipeline, right? The shader groups and the shaders is sort of this stuff right here, right? Which is also this is a shader. Notice that it's a different file. Okay, so we have the ray tracing shaders, and we have is GLSL. We have the closest hit, miss, and raygen. So this is the raygen, this is the miss, and this is the closest hit, right? So we have our ray tracing pipeline, we have our shaders, And then we have our acceleration structures, right? So, right, we have our top level and bottom level acceleration structures. So, the bottom level acceleration structure is for the create bottom level. So the bottom level acceleration structure is actually the geometry, so the triangle in our case. And then the top level acceleration structure is scene's actual geometry, vertices and triangles, right? And then the top level acceleration structure has contains the scene's object instances. So I believe with the top level acceleration structure, you could create multiple triangles, right? If you know, so it's like making multiple instances of the same thing. So, and then know that like once you create the bottom level acceleration structure, you can only access it or sort of deal with it through the top level acceleration structure, right? So, right. So we have our acceleration structure, we have the ray tracing pipeline, and then we have our shaders here, right? And the shader binding table is supposed to link up all these things, right? And it has something to do with memory. We see a lot of buffer conversation here because you got to create a buffer. So right, so raygen shader binding table, miss shader binding table, hit shader binding table. So notice that we have three shaders, right? We have three shaders, 1, 2, 3. And then we have three, I guess you would say three shader binding tables. So we have the raygen shader binding table, miss shader binding table, and the hit shader binding table, right? So the number of shaders, I guess, is supposed to match with the number of binding tables that you have, okay? And that's why you see all these buffer references, right? So anytime you see buffer, you know you're talking about a storage container, you're talking about memory, you're talking about buckets, right? So that's my understanding of buffer. So create shader binding table. So we have we have we have the shader binding tables, and then there's a whole bunch of functions. Okay, so this one is pretty important. The vkGetRayTracingShaderGroupHandlesKHR. Okay, so now remember I said shader binding table is linking ray tracing pipeline, acceleration structure, shaders, and you know, basically you're trying to you're trying to interface the two, right? It's like a cable, you're connecting the two, or a bridge. So the get ray tracing shader group handles KHR is sort of in the ray tracing. Well, let me just rehash. Hold on. Let me just rehash this conversation here because right. So this VK lowercase vk, so we know it's important. Get ray tracing shader group handles KHR. So this is supposed to help us to plug into the ray tracing pipeline, right? But we need to know, okay, what are the handles? You know, what are the handles that sort of plug into the pipeline? So this VK get ray tracing shader group handles KHR. Right. So notice that it references a pipeline. So of course the device is the Vulkan logical device. This function references, or one of the parameters is a pipeline. Now this pipeline, of course, is the ray tracing pipeline, whose shader group handles are being queried. Right. So we're trying to get what the shader group handles are on the ray tracing pipeline. First group, index of the first shader group to retrieve the handles for, and then group count is the number of shader group handles to retrieve starting with first group, right? And then data size, SBT size is the data size. Right, and this is the block of memory where the shader group handles will be written. Okay, so block of memory where a pointer to a block of memory where the shader group handles will be written. So let us okay, so this is okay, so we have the shader group, shader binding table size, which is group count times handle size aligned, right? This is like kind of memory related stuff. So we have our SBT size, okay? So then we create a vector called shader handle storage, right? And that vector is of size SBT size, okay? And then what we do is we mem copy region shader binding table mapped. So we create a buffer here, and then we basically connect the region shader binding table to the shader handle storage data, right? And then handle size, right? So I guess this is the initial operation. So we just start with the very first. But then notice that for the second one, for the miss shader binding, remember this is like a strip of memory, so you have to move the needle. So for the first one, we put it here, and then we have to move the needle for the second one, and we have to move the needle for the third one. So notice it's just the data for the first one, but then it's data time. Plus added in handle size aligned, right? For the second one, and it's handle size aligned times 2 for the third one. And handle size aligned is this guy right here, right? Which is a whole nother conversation, right? So let's just look at it real quick. Ray tracing pipeline properties, shader handle size, group handle alignment. Okay, so this is another thread which I'm not going to get into right now, but basically we're using this handle size aligned to sort of move the needle on the memory. So for the first one, we just put the data. For the second one, we move it once, one handle size aligned, and for the third one, we do handle size aligned twice, right? So times 2. Okay, so that is basically connecting the shader binding table with the shader handles on the ray tracing pipeline, right? Right. So vkGetRayTracingShaderGroupHandlesKHR is a Vulkan function used to retrieve the shader group handles for a ray tracing pipeline. These handles are essential for building the shader binding table, which links shader groups to the resources and data needed for ray tracing. All right, so right, the shader binding table, from my understanding, it's something intimately inside of the GPU that is like on the GPU, and it's something the GPU uses to manage resources and all that good stuff, right? I am curious. I'm just gonna comment out this guy right here, and I just want to see what happens if I just don't map the miss shader binding table, right? I want to see if it crashes or if the application runs, or I think it's good. Ha! All right. Look what we got, guys. All of a sudden our miss our miss stuff is our miss rays, right? So rays that basically didn't hit any geometry or anything. All of a sudden that's blank. Now it's blank, but we gotta investigate. Notice that even though it's blank, like the application still runs, right? That's our that's our you know, that's a good a good thing, is that number one, the application runs, it doesn't crash, it doesn't have any issues. But we noticed that the miss shader, remember the miss shader was like, you know, if you don't hit anything, make the color blue. Well, the miss shader is just missing completely, and that makes sense because the ray tracing pipeline doesn't have a miss shader. It doesn't see the miss shader because we basically commented it out. All right. So let's do the raygen one, right? So we're gonna take out the raygen, we're gonna put back in our miss, right? And you guys gotta guess before I actually pull it up. You guys gotta guess what's gonna happen. We're not the ray tracing pipeline is not aware of the ray generation shader, right? So the ray tracing pipeline is not aware of the ray generation shader. So what's supposed to happen now, right? What's supposed to happen? What's supposed to happen? Nothing, blank, right? And that makes sense because we're not generating any rays, so there's nothing to see. Like, there's no rays for a hit, there's no rays for a miss, and there's no rays, I mean, there's no ray gen anything, right? So we just get a blank screen. All right? So you guys are in agreement of that. We kind of expect that. Now let's do so we're commenting out the hit shader now. Now we're not actually getting rid of the shader itself. We're just telling we're just not letting the ray tracing pipeline know that the hit shader we're just not telling the ray tracing pipeline that there's a hit shader, right? So what do you guys expect to happen if everything else is there, the ray gen is there and the miss is there, but then the hit isn't there? What do you guys expect to happen? Talk quick before I show the application. What's gonna happen, guys? What's gonna happen? Talk quick. All right, you've made your decision. Survey says that we basically have a whole bunch of misses and no instructions for a hit. So rays are being generated. We have instructions for misses, which is blue, but we don't have any instructions for a hit. Okay, so it just basically makes an outline, right? So this is kind of like you know, you're not giving instructions for this, so you just get a black triangle. Okay, maybe that's what you want, right? All right, so let's just do a final thing. So we're gonna basically tell the ray tracing pipeline that there are no shaders, right? What do you expect to happen? There are no shaders. There's no ray gen shader. There's no miss shader. There's no hit shader, right? There's just nothing. What do you expect to happen? All right, talk quick. All right, so let's go now. And we have a blank screen, and that makes sense, right? Application doesn't crash, it still runs. We have a blank screen. All right, so that's basically where I want to I mean, I don't want to dive too much more into it, but just understand that these are all this is all just it's just basically managing memory on the GPU, and the shader binding table is sort of interfacing between the ray tracing pipeline, the acceleration structure, and the ray tracing pipeline. And the external shaders, right? So, right, so we're back to normal. We get back our triangle. Okay, so, all right, guys. So the thing about it is that I kind of want to know, like, how does this... So I understand the shader stuff, right? I understand the shader stuff, right? So obviously we get the handles into the and the handle is really just a handle. It's just like, okay, what are the handles? Like, it's almost like you're picking up a bag, or you're picking up the handle on sort of a something, right? So they're really handles like into the ray tracing pipeline. So I understand that. I understand the memory operations, and I understand linking the handles with the RayGen shader binding table and all of that. Like, I kind of implicitly get that, because that's like, this stuff here is basically related to this stuff here, right? So that's how we get our shaders and stuff. And you need to tell the ray tracing pipeline about the shaders and all that stuff. I get that. All right. My remaining question about this though is, okay, how do you get to the acceleration structures, right? It's not exactly clear to me how the shader binding table relates to the acceleration structure in the code. So like, is it sort of implicitly, is it like a one-way street where the shader binding table interacts with the shaders, and then the shaders is what interacts with the acceleration structure, and that's kind of how it's all looped in together? Is that the line of logic? Like, how do you go from the shader binding table to the acceleration structure itself? Because everything here, I don't really necessarily see anything directly related to the acceleration structure, right? So I'll try and address that question in a later video. Create the shader binding table that binds the programs on top level acceleration structure. Shader binding table layout used in this is this sample: RayGen, miss, and hit, right? So create the shader binding tables that binds the product programs and top level acceleration structure. Shader binding table layout used in this is sample, right? So I guess it's just implicitly part of the top level acceleration structure. Let's go to the top level. All right. No, I don't really see anything. I think it's just implicit. It's just implicitly implied that the shader binding table through the shaders themselves, this is the shader now. So I know that the shader, yeah. Question of the day. So anyway, that's pretty much where I'm at right now. Right. So this is my next addition to the shader binding table conversation. Like and subscribe, guys, if you want to run this example and have all these examples. You need to get tutorial number 1, which is installing the Vulkan SDK, and tutorial number 13. Tutorial number 13, which is installing. So tutorial number 1 is installing the Vulkan SDK. Tutorial number 13 is installing the these examples here, right? I assume you have a Windows-based machine with a Vulkan-capable GPU. If you want to be able to run the ray tracing examples, you need to make sure your GPU is ray tracing capable. For NVIDIA, that means RTX and above. For the AMD and Intel, I have no idea. But for NVIDIA, you need RTX and above. Okay, so that's where we're at with this, guys. Tell your friends about it, like and subscribe to the video. That's where we're at, guys. Thank you for watching. Have a great day.